Alright, so we're back here. I've just reviewed a few of these videos, and man, these are classic. This might even make it onto my best of the best highlight CD. Anyway, just don't go home and have your parents watch this and figure out what a crazy person I am. Okay, so letter D, we're going to say from the work of de Broglie, Heisenberg, and Schrödinger, we have the wave mechanical model of the atom. It's going to have these four postulates or ideas. First is that electrons behave like waves. Now what that means, again, from the video and from this kind of explanation over here. To find an electron, we use the Schrödinger equation, and when we solve it, we will get geometric shapes. Alright, ask your teacher for math what I'm talking about there, how a mathematical thing defines a shape. Alright, like a circle, I think is x squared minus x, I don't remember, whatever, x1, x2, y2, that's a line. I don't know, but a circle has its equation. You know, you're in 1060. It's been 15 years since I was. But we can use math to find shapes. That's the first one. Alright, electrons in atoms have specific energies. Okay, let me erase. Well, no, I'll erase right here. Now, if you remember, over here was the Bohr model. Alright, we had these levels, and we said those were energies. We're going to say the same thing here, but now instead of rings on a ladder, we're going to say that they reside in these funky shapes, and that the different shapes that they reside in is defined as their energy. Alright, I don't know why I'm drawing this again. It's already over here, much clearer. Alright, so that's that. 3 electrons are arranged in certain energy levels. Those are the orbitals, and now instead of rings, they're going to be shapes. For some reason my computer's slowing down. That's not good. Alright, the electron location can be described as electron probability cloud. Alright, now it's slowed down again. Alright, so these circles or these dumbbell shaped things that we're looking at, we're going to call a probability cloud. It's the voluminous region around an atom where you will most likely find the electron. Alright, this is one of the goofiest, funnest videos that I've ever recorded. I want to find some pictures that better illustrate this, so I'll pause it and get right back to you, even though in your time it won't be any time at all. Alright, I just did a super fast sketch or search. I found this. These are the P clouds. Those are the ones I drew up and down, left, right, and in and out of the board. That's called the X, Y, and Z plane. Alright, and they're just, once again, the regions where the electron is most probably found, and their weird shapes are defined as the answers or solutions to the Schrödinger equation, which is a wave function. So once again, the electron is a particle. It behaves as a particle, but its location and other characteristics are defined by waves. Alright, let's go back to this. Alright, if I remember, I don't have it on here. Well, I guess I can look. That's easy. Alright, it says, why was the wave mechanical model of the atom developed? Alright, you need to think back to what we said a half hour ago. Think about Rutherford's trouble with his explanation of the model. That's the main reason. What did Rutherford, even though I said it was Bohr, but what did Rutherford in the movie, what did he realize was wrong with his model that Bohr then explained and then was developed further on by Heisenberg's uncertainty principle? Try and explain that. Then it says, because electrons behave as waves, they move in different patterns. Draw and label the s and 3p orbitals here. Alright, so s, spherical. Oh, I have the wrong thing open. Spherical, the other ones look like those images.